Hello, my name is Callum McNeil. Welcome to Callum McNeil Does Plato's Forms. Today we're going to go through the Plutonic forms. And the first one here is the Tetrahedron. Now, the basic concept of the forms from Plato is the idea that there's an ideal place in the world where the forms exist, and that's how we know them. Now, this quasi-state is really misunderstood by him. And what we really want to do with the forms is we actually don't want to do that. We want to just explore what this simple form of tetrahedron gives us. When we look at the tetrahedron, it's the strongest shape in nature. It's beautiful by itself. One interesting thing about the tetrahedron is it can't completely observe itself. It can't completely observe itself. Now, what does that mean? It means that if you take a tetrahedron and you try to complete the structure of the tetrahedron so that it is finished, you can't, because you see the gap at the top. The structure of the tetrahedron is such that it doesn't make a perfect shape. It's actually impossible for the tetrahedron to observe itself. Now, what does this mean? This is inherently or intrinsically or something you know in the deep inside yourself. It should make itself work, but it doesn't. So what happens when we continue this pattern out and we accentuate this crack? What happens if we, as Plato says in other places, that all the world is a sphere and all the universe is a sphere and all of everything is a sphere? And so if we here trying to complete itself, you see, the square can do it. The square can make a perfect grid. The octahedron can make a perfect grid, but the tetrahedron can't. It can't observe itself. So here's some other examples. Now what we have here is literally what happens when the tetrahedron, I've made that so that they're all perfect triangles. And when they try to observe each other and make the ball, it's a 20-sided piece, but it's not perfect because it can't observe itself. I know that's such a hard concept to try to nail into, but we're going to get into that a little bit later. But just go with me on a couple of these shapes. So this is, if we count the number of tetrahedrons in this structure, there are 20. This is a 20-sided structure that is imperfect because the tetrahedron volume cannot make a ball. Here we have another one. Now this one is the most interesting to me. This is what I believe the actual shape of the black hole is. We'll get into that later. But you can see this would be the two sides of the white space and the white jets, quote unquote, and then the dark sides. Now I believe that we can only observe it like this. So we can only observe it when this bottom is angled at us, and it's impossible for us to observe it at this angle. So I believe there's an actual orientation to the black hole that gives us a spin. Anyway, but if we go back to this shape, the tetrahedron can't observe itself. Again, we're smashed into a. What we did was we took the tetrahedron. I'm going to take my blue triangles out of here so it makes it a little more easy to see. We took the tetrahedron and we started down here and we built it out so that we're going to take the tetrahedron at the bottom. We're going to build it out, and when the crack observed in this shape, the four-sided, see that diamond crack is right there. See that crack? Boom, boom, right there. So what we did was we took that shape, we built it in, and then we built it out so that everything that is not was all localized into one place. And it came into this beautiful pattern. There's the Z, the zigzag. Now, the part that is shared is the blue triangle, and then it's cracked all the way up. It's cracked all the way through here. Doesn't touch, doesn't touch, doesn't touch, doesn't touch, doesn't touch, doesn't touch. Goes back to the blue triangle. So the sphere is split in two perfectly. A yellow side and a red side. And it's 10 tetrahedrons on one side and 10 tetrahedrons on the other side. And that other shape I showed you is the exact same. This shape. Now this shape, to make this shape, I had to, you have to have one of the tetrahedrons not in place. So to put that shape together, all those are solid tetrahedrons. But then to put it in place, and it all clicks in, see this one spot right here, it's missing a tetrahedron. If we put that in place, it locks it all in place. Okay. So there's the basic forms. Now I know what you're saying. You promised, Callum, that you said that there'd be some level of understanding. Yes, this shape cannot observe itself. So what does it do? You see, what happens is here's another version of it. You have 10 tetrahedrons this way and 10 tetrahedrons in the opposite direction this way. A left spinner and a right spinner. And they'll click right in together. But they're not quite perfect. Do you see that? See, that doesn't, it can never observe itself. So what it does is a trick, you see. And it does a beautiful, beautiful trick. I don't know if you can see this, but basically, it takes the bottom is the red, and the top, I think you can see it. Let me simplify it. So that's what it came into. This is what it forced. Now, what does that look like to you guys? That's the tetrahedron observing itself. I just showed it to you. The tetrahedron observing itself. Now, can we take that? And do you see this? Do you see this? Do you see the cross right here? And do you see this Star of David right here? Do you see the Star of David? Do you see it? The tetrahedron, observing itself through the other tetrahedron, makes the Star of David. Now, the beautiful thing about the Star of David is that it's also it's also a box. It's also a box. How is it a box? It has 8 corners, and the Star of David has 8 corners. So the Star of David's sitting right here, but when we set it down like this, it instantly becomes the box. The box is right there. Does that make sense to everybody? So the Star of David is the tetrahedron observing itself. Pretty easy to understand. But what is the box? What is the box? Well, if we take the Star of David apart, and we fold down the box, we get the cross. We get the cross. So in the Star of David and the square relationship, in the star tetrahedron and the square relationship, we have the Jewish and the Christ relationship. We have the Jewish and the Christ relationship. So let me say it again. So we have the tetrahedron, the regular tetrahedron. The regular tetrahedron. It is trying to observe itself. It makes a whole bunch of itself, but when it tries to fill in the gap, it can never fill in the gap. It fills the whole universe up, comes back to itself, observes itself, makes the Star of David, and the Star of David observes the cross. God, that's beautiful. I don't know if that translated well. I don't know if this mic worked. This is the first time ever I've put this down onto recording. But I just wanted to do the forms with somebody. Thank you for doing the forms with me. I've never shared any of this with anyone else. So this is the first time. If you like it, please leave your comments in the comments section and get in touch with me. Cheers.